Thank you very much. So yeah, first of all, I just wanted to thank you again, Marie and Lionel, for making this seminar, organizing the seminar, the workshop. So this is actually, so at first when you offered me to present, you had in mind a paper that I did with Peter Egger and Marco Guttenberger at ETH. And this is a paper where we looked at municipal mergers in Germany, and the idea was to try to track economic activity. And since, I mean, we know that kind of municipal mergers, they kind of involve a reduction in the number of units, because before you have two or more municipalities, and then you just have one. To be able to track kind of the units after the merger, we're using nightlight data, which I think was quite a nice feature for this. And but kind of naturally the issue with this is that we solve one problem, but it's difficult to interpret, what is really emitting the nightlight or kind of the activity or the effect that we observe. And so this paper, and so that's I was offering to present this paper, which is a brand new paper. It's actually the first time I'm presenting it. And this is actually a single author paper where I try to basically go one step further and try to understand, how borders affect economic activity, and actually looking at kind of more real standard economic activity outcomes. So the title of the paper is "Are Regional Borders Invisible?" So to give a bit of introduction, a bit of context to this paper, I think the first thing which we are probably all aware is that regional borders are very common in today's economic geography. I mean, we see them everywhere. What I mean by regional borders, just a quick definition, I mean kind of all administrative units between the national and the municipal level. So that's the US states, European, that's 2 or 3 regions, the Chinese provinces and prefectures, this type of units. And in total, if you take the GADM data, in 2019, there was 9.7 million kilometers of regional borders, defining almost 50,000 jurisdictions. So, first thing, regional borders are very common. Second thing, they are crossed every day by millions of commuters. I mean, if you look at data from the US, Germany, or France alone, just data that I found, you have 13.5 million commuters overall that cross, that reside and work in different regional units. So this is across state borders in the US, across Kreis borders in Germany, and across departmental borders in France. On top of this, or what makes this kind of border crossing so frequent, is that since they are within country, they are, it's kind of a homogeneous socioeconomic environment, and very importantly, you don't have any border controls. Kind of the only thing that you see when you cross a border, on the road, there's a kind of sign on the side of the road saying, okay, you enter a new region, and that's pretty much it. So, regional borders are very common. They're crossed all the time, every day by millions of people. So you think maybe they're not that important for economic activity. They're kind of there, but do they really matter? That's kind of on one side. And on the other side, we know that regional borders are not kind of just an artifact. They delineate jurisdictions, regional jurisdictions, which are often in charge of a wide array of policies. And this includes typically the planning and development of local transport networks, which, if you look at the literature, kind of the regional literature, the transport literature, we know that this has a strong effect, kind of transport network have a strong effect on economic activity. Just to give you a key figure, so in France, this regional network represents 71% of the total length of the road network. So kind of from this, just to give you this motivation, you have on the one end, regional borders are very common, crossed all the time. Maybe they don't matter so much. On the other end, they seem to determine something that's very important for location of economic activity. Hence the question in this paper: are regional borders invisible to surrounding economic activity? So what I do in this paper, I combine spatial quasi-natural variation, looking at French departmental borders, with a spatial QGE model. I establish, I think, robust evidence that regional borders do matter, do affect commuting flows and local residential counts. So what I kind of as key figures to key results from the kind of quasi-natural part of the paper, there is a discontinuity in the likelihood of commuting across the border of 52 percentage points. So when you live at the border, by residential location, you are far more likely to commute, to go to work within your regional unit than just across the border, even though kind of the great circle distance or the bird distance from one side to the other is just a few kilometers. And so this is for the commuting part. For the residential part, I find that if you were to rank for each border, the smaller labor market and the larger labor market by size of the labor market, this is simply the sum of all employee or all workers in a region. And what I find is that you have kind of an excess mass of a residential population above the border, so on the side with the larger labor market of about 145 residents. Then once I've shown this kind of basic or small first quasi-natural picture, I try to understand, okay, why do they seem to matter? And what I do is that I show that decentralization seems to be a very important driver of this, and especially that actually when you look at travel distances around the border, what you see is that to cross the border seems to be associated to kind of a penalty. It just takes more time to commute the border due to the transport networks that are not perfectly integrated, which is estimated between, depending on whether you take a structural or reduced form type of approach, between 12 and 19 kilometer penalty. And what I think I like there is that I also take the model, kind of reverse the general equilibrium model or structural model, and try to see, okay, how large would that gap need to be so that the patterns that we have on commuting flows and residential counts, how large would it be so that we rationalize these patterns. And what I find is something exactly in that range. So in a sense, decentralization may not be the only factor there, but it's very likely to be a major player. And then finally, once you have kind of a calibrated model, I think it's kind of going one step further to just run the simulation to try to see, okay, what if we take away this border penalty, if we integrate local networks, what would be the kind of the gains, what are the economic effects from this? So then I run a kind of a cost benefit analysis, and what I obtain is on an expected 9.5% median growth in real per capita residential income. By real here, what I mean is that it's the income divided by the prices, so price of some consumption good and housing. So the paper, I think there are 4 innovations in this paper, for contributions, distinguishable contributions to the literature. The first one is that I apply a spatial discontinuity estimator to commuting flows, residential density, and travel distances at regional borders. The second one is that I tackle the issue of endogenous or potentially endogenous border placement, which is something that is not too commonly done in this type of designs, which normally rely kind of on the idea that you make a kind of covariate test around the border and things like this, which I think here that's quite an interesting way to tackle that issue. And to do that, I use an historical geometric border design that was proposed during the French Revolution, and that is actually the inspiration for the actual design. The third innovation or contribution is that I find a way to mix, or I mix the kind of a structural model which I inform with quasi-natural moments to study how decentralization or a jump in travel distances might affect commuting and residential patterns, which I think is quite nice. I mean, in a sense, this is something that's a bit in the flavor of what like Daniel Shu on the China notches, R&D notches has done there. So that's the third point. And the fourth is to study kind of what happens if you integrate transport networks. In general, it's kind of a framework. You could all do any type of counterfactual. As always, I think this is the most natural one. So I also bring this to the table. For the literature, I will go quickly there. I think there's mainly 4 large strand of work that matter, or that matter that to which this paper really relates. I make a distinction. This is not, I mean, there are different papers where distinction is actually not perfectly easy to do, but still there, I think it's you can kind of find two big categories when you look at borders. One is papers that actually study the effect of borders. That's typically the border effect in trade at national borders mostly, but you also have the Vrona paper from 2018 that, within country using Japanese data, but also agglomeration dispersion forces within cities. That's the Berlin paper from Alfeld and Al 2015, the cross-border commuting or growth rates. So basically looking at really the effect of borders. And then there's another strand of the literature that uses borders as an exogenous source of policy variation in space, which is a little bit different in the sense the border is not the thing that is really interesting or it's not the targeted moment, but it's using the border or variation at the border to understand a question that goes beyond the pure border effects or some border effects. So that's probably the two big strands to which the paper talks the most. Then since there's the model or structural framework that I'm using is inspired from, or it comes from the kind of urban equilibrium literature. It connects to that literature and to the topic on fiscal decentralization. So once this is said, I just want to highlight three facts about French departments, which make which make them an ideally suited, I believe, an ideally suited border to study this question, or the question on how do they affect economic activity. The first fact, or fact one, is the fact that the actual design that we have today is inspired by a proposal that was made during the French Revolution, so 1789, by the CES committee. So the pre-French Revolution, so before 1789, the French administrative division was extremely complex. So it was made of provinces, of military jurisdictions, of tax jurisdictions. So and they didn't always perfectly overlap. So it was very complicated, very complex. So the French Assembly decided to remodel this, to redesign borders, and they asked the committee. This is the CES committee for the French. Among you, CES was one of the kind of one of the key political figures during the French Revolution, and that committee proposed a geometric design. So this is the one that you see here with these squares of 18 league, which is approximately 100 kilometers, which is a perfect, really just a symmetric. Basically, you take a ruler and you draw lines, and you draw squares, and that's it. And then it was supposed to be subdivided further. In the end, that design was not adopted, which I think we all have good reason why this very geometric design it seems a bit crazy, but it was a very strong inspiration for the actual design, and we do see typically the shape, the size seems to still be quite close to this design. So this is the first fact, and of course I think you already see me commenting that I will use this as in an IV strategy. The second fact is linked, is the fact that department borders do not always or rarely actually follow natural features. This is because they try to, kind of inspired by this initial design, they didn't follow typical natural features. They try to have things of similar sizes, which is what I represent here. So kind of these darker bold lines are the actual borders that didn't change since 1964. And all the changes pre-1964, I just want to say this, that most of them, the vast majority, this is just movement of the French territorial extent, Alsace-Lorraine moving and things like this. Exactly. So they don't really follow natural borders. And by natural borders, what I mean is mountains or rivers. That being said, they're still it still follows sometimes. I mean, you see typically kind of on the north-south axis here, you do have kind of a river and a border coinciding. But in many instances, which what you see here, this is not the case. So there are two ways that I deal with this. So what I'm saying so far was it was maybe not too much of a problem. That being said, to be sure, I do two things. So first, the IV strategy helps in that regard, which I will detail in a second. And the second one, I just discard location close to natural features. So basically, I just run the analysis the normal analysis as if it was just just looking at planes location. So this is typically something that Black 1999 or Ehrlich and Seidel 2018 have done to deal with this type of concerns. The second thing is that local departmental public finance, public finance or the local departments have relatively little autonomy on the public finance side. So there, I'm not saying that they are not important in the sense that they don't, have a lot of responsibilities or they're not responsible for a wide array of policies. What I'm saying is that the autonomy is relatively restricted. So on the spending side, it's mostly mandates. So they have a little autonomy of, you have a little variation across space for this. On the revenue side, it's basically mandates or transfers or fixed tax rates. The only main or the one thing that departments do have really quite some freedom or some autonomy on is they are able to influence about 20% of their revenues via a local land value tax. So this is still something that's important, and in each department you could have you can have differences in this, and then you might have tax competition and possible effects on residential location commutes that could confound the result that I will present to you. To tackle this issue, I think I do two things. So first, since there are many departments, many borders, I can actually include fixed effects which control for tax rates, and then I can control for the tax base because the tax base is basically housing prices, and I have housing price data at the local level, so I can simply control for this in the estimation strategy, in the estimation. So once I gave you this kind of three facts, I want to, before jumping to the framework, show you two descriptive evidence, this is really just plotting some averages on commuting and residential residential count. So the first one is looking at commuting around borders. So commuting is a little bit difficult to display because it's a bilateral outcome. So people, will commute from region A to region B, and others will commute from region B to region A. So it's, you need to kind of organizing or putting this region in a way that makes sense. So what I did here is that I'm basically saying, okay, for each region, let's look at it as a destination, and let's look at the share of people that commute to that destination, that region, that I call region B, before the border and as you cross the border. And so basically what you have here, if you can see the mouse. So what you have here, this is the share of people that are residing in region A and that commute to region B, distance to the border. So these ones are 5 kilometers from the borders, 15 kilometers from the border. And here what you have is bins of 1 kilometer of people that are residing in B and work in B. So that's the people that reside and work in the same department. And clearly what you see here, you have a huge jump. So about 20% of people are in A are crossing the border, and just a few kilometers, 1 or 2 kilometers away, that proportion jumps tremendously above. So that's kind of this is really just descriptive evidence, simple averages by 1 kilometer bins, but it seems already that something is happening there. So that's on the commuting side. On the residential count or residential mass, so I'm looking at count and not at densities, because borders, municipalities might just differ a little bit, and I think residential count is probably a better measure, but you could divide by density. They are all just on average, to give you a bit of figure, French municipalities are very small. You have almost as many municipalities in France, I think, as in the rest of Europe, or something like this. So they are on average, they're about 5 square kilometers, more or less, in size. So here, what I show is the residential count, and the way this is organized, it's a bit easier to organize, because it's not by, residential count is not a bilateral variable. So what you have on the left side, you have the smaller labor market, and the right side, the larger labor market. So this is simply, you have a border, you look at which one is the larger or smaller labor market, and you just orientate in a way that you have positive distance to the border for the larger one and negative distances for the smaller one. And what you see is that you also have a jump at the border of about something like 200-300 inhabitants or residents here. So again, it seems that the border seems to have an effect on residential count. So to model this, I apply, or I use a spatial QG framework. I'm building on the Monterrey-Dingrosiansberg 2018, so that's a AR paper. It's a model of commuting openness in a spatial equilibrium. I think this is a model that kind of really targets commuting, which is also the main moment that I have here. So this is why I think it's a well-suited model to analyze this question. The framework, probably the one key feature here that's important, is that the framework so models agglomeration gains as kind of standard in the economic geography literature, kind of low varieties and increasing returns to scale. So basically, the key thing is that you have benefits from agglomerations. To this framework, basically, I take the framework, I make too small, or I add 2 ingredients to this framework to fit it to the present the present question. So one is that I add a central institution, which is in charge of integrating local transport networks. The costs to integrate are financed via an ETH tax that is levied on all workers. Why I take a ETH tax? There's no theoretical, it could be any progressive, it could be any tax. It's just the ETH tax had this nice advantage that once I have a cost for 1 additional kilometer, I can match it perfectly to a ETH tax, because I just levy X number of euros or dollars from workers. So this is why I made that decision. But there's no, from a theoretical perspective, there's not much there. The second ingredient that I add is that I allow residential floor space, to be endogenously determined by total residential income. This is the product of population times residential income. So total residential population times total income. The idea is that if the effect is large enough, you don't want to have some type of anchor from past historical residential density. That just limits the effect, whereas we know in the real world that if many people want to go to a new municipality, probably municipality might make its law evolves and its kind of planning evolve to allow for this. Since I don't really, I don't think the contribution in this paper is much on the framework. I will just skip it. But if you have any questions, feel free to ask about it. So now I turn to the natural experiments. So at regional borders, this is trying to put a bit more, or try to get a bit more of causal link to the descriptive evidence that I showed you earlier. Yes, exactly. So the idea that you'll see that I'm using a discontinuity estimator. What I like with this is that later on, I'm using a very structured approach, and I like to have some first effects that are using really a minimal structure, minimal framework, or don't put too much assumptions on the data. So the objective is to identify a treatment effect tau of either crossing the regional border or being located on the larger labor market for residential count. The way this is kind of often presented is that you want to look at the and you'd like to be able to observe for the same individual the two kind of the treated status and the non and the control status really at the border. Of course, this is not available. So what we do is that as distance to the border gets to 0, we try to compare outcome on one side versus the other. The idea being that when you're really very close to the border, you start to have very similar places. Exactly. So this is what you have in equation number 9, with R plus being the one on the other, the region on the other side from perspective from municipality N, and R minus is the one where N is located. So I approach this in a parametric, non-parametric specification. So parametric, I use a wide array of polynomials and bandwidth, and the non-parametric, I follow the Calonico et al. 2014 approach with. So this is optimal bandwidth and optimal. So I follow their tools or their approach to get an optimal bandwidth and optimal polynomial order. And I also, the key thing, as I was talking to you earlier, telling you earlier, I use an instrumental variable approach to tackle the issue of the endogenous border placement, where the IV, where the IV. There, so I'm using in the parametric case, I'm predicting the actual distance to the border, so actual great circle distance to the regional border by the great circle distance to the CES border, so this geometric border. So this is in the parametric case, kind of standard IV. And in the non-parametric, I'm using the distance to the CES border as the forcing variable. So basically, I replace the distance to the regional border by the distance to the CES border. So the key result, I'm showing you here the IV results. What we have is in line with what we saw before, a treatment effect that is positive. You get, when you just look at IV, you get quite large coefficient. This is in a sense because you have this is a linear model on a percentage, on a share, and where treatment effect is very large. It's not too surprising that you get point estimates away from this. So this is why I tend to prefer. So I also estimate a fraction response model, but that's why I kind of prefer the non-parametric approach, which gives you this 52 percentage point effect, which is what in line with the descriptive evidence from earlier. The standard RD plot with a 25 kilometer bandwidth, same thing, in line with the descriptive evidence from earlier. Now turning to residential count, same thing, IV and non-parametric. You see there's a strong difference in the number of observations. So the optimal bandwidth in non-parametric seems to be much wider there. You get a much smaller coefficient. Because it's conservative, I take this one. I find I wouldn't take this one because there's a big difference in the weak in the instrument test. So I would favor this one. So potentially the non-parametric is a bit underestimated, but since it's in line with the descriptive evidence, I tend to also in that case like the non-parametric estimator. I also approach this as a bunching problem, but since you really have kind of two levels around the border, I think the RDD is the right way to go. And with the benching, you get about 262, I think, exactly 262 as a discontinuity in residential count. The following RD plot, which is similar to descriptive evidence. So hopefully by now, you're convinced, or you think as I do, that regional borders do matter for economic activity, and by this I mean for commuting and for residential count. And the question is then, why is that the case? To do this, I take kind of a dual approach, or a two-step approach. In the first step, what I do is that I based on intuition, I think, okay, probably the kind of the decentralized planning of regional transport networks might be important. So I test whether it's important. That's the first step. And in the second step, I see, okay, given that it seems to be indeed important, how important is it, and is it that important that you can rationalize the full effect on commuting and residential density? This is exactly what I'm doing here. So why would decentralization matter? Kind of the why of the why. So the French departments are administering a regional road network. This is 71% of all road length in France. And each unit is sole responsible for its jurisdiction, right? So there is no institutional setting that fosters convergence at the regional level. At the region, there's no integration. There's no institution that makes it at the local level. You have some type of integration force. So absent such setting, you can look at the looking at the literature a bit, what you would expect, especially from the kind of experimental literature. This is may be, you might have possibilities of some type of coordination failures. Two regions have different parties, different business cycles, different interests, and you need to trust that the other one will build the connection to the on his side of the border, so that you will do it. And if you don't trust that person will, that the politician on the other side will do it, then you don't engage into it. And in the end, you might end up in a kind of might fail to get the dominant equilibrium. There are did examples, kind of small case studies. So this is these two papers from 2018 and from 2020 that actually look at this in the case of transport networks. I think both are in Europe, one in Belgium and one is more on the EU study, and show that indeed this seems to happen on a case study basis. So the question here is, do travel distances jump at regional borders? What I see is that indeed, when you approach this in a linear or in a kind of a parametric framework and a non-parametric, what I have here, what I'm showing you here, is the commuting distance along the road networks to the centroid of region B. So how much it takes when you are 7 kilometers away from the border to go to the centroid of region B. And this is the parametric way. So you have one omitted category. So this is the municipalities at -1. And what you see is that on one side of the border, on region A, you have no difference. And as soon as you cross the border, suddenly you are 20 kilometers closer, or 19, 20 kilometers closer to the centroid. You're just much faster, really at the border. Whereas actually from a great circle distance, you only moved by an average one kilometer. Same thing, you get a similar effect when you look at the non-parametric. There's no omitted category there. So indeed, there seems to be a jump in travel distances. So decentralization on transport networks seem to affect and create a jump, or that's how I rationalize the fact that you do see a jump in travel distances. Now, kind of going back, can this jump explain alone or not, or how much can it explain the quasi-experimental results on commuting and residential density? So what I do, in the framework, in this general equilibrium structural framework, I parameterize the distance function, the commuting cost function, as a function of the great circle distance plus a penalty for crossing the border once. So if you cross any regional border 20 times because you're kind of across the country, that's, you still paid only the cost once, and then the kappa, this is the transfer of distance into costs. And I estimate then this in a structural way with in the generalized method of moment type of approach. I focus on these 3 parameters where kappa is the elasticity of distance, and nu is this penalty, the one that I'm really interested in, and epsilon, that's the Fréchet shock, for those that are familiar with this idiosyncratic utility shock. Normally, once you have a kind of framework like this, you can match on different observed moments of the data. I think it's quite nice because since I have these experimental or quasi-experimental moments, commuting moments and residential moments. So this is the town commute 0.52 and residential 1.45. I can actually choose or find these parameters, search for these parameters that make this the most likely. And the parameters that do this are these 3 parameters. They're very precisely estimated. These 2, so kappa and epsilon, are very standard in the literature, and what I find is very close to what is commonly found, and even to a surprising extent, because these 2.00. This is even the value that is often assumed from the literature, kind of a exact value or rounded value. So this is particularly surprising, but yeah, in general, it's in line with the literature. And what I find very nice, or what I find very interesting here, is that indeed the cross-border distance penalty, this new, that makes the residential and commuting discontinuity the most likely to be as close as what we do observe. This is in that range, so 11.994, which is a bit smaller than what we find here. But given the confidence interval, it's actually not really distinguishable, right? So in a sense, it seems to be quite close. So from this, I'm kind of I'm concluding that indeed this discontinuity in travel distances seem to matter to explain these results, and to matter very much. So there might be other things that apply here, but they don't bring they probably don't bring that much. Okay. So this is kind of try to understand these general patterns of the discontinuity and the mechanism behind. And now I'm going to the last step, counterfactual policy, using the framework to analyze the integration of the regional network. To do this, I need to add to the calibration exercise. So I do this in a kind of reduced form, kind of an additional or subsequent reduced form approach. So one thing that I need to add is the amount of the missing road that you have close to the border. And that's kind of another piece of evidence that indeed, when you compare the density of road kilometers that you have per square kilometer around the border, so between 0 and 4 kilometers of a regional border, and between 4 and 8 kilometers from regional border, you do see that there's a missing kilometer per square kilometer around the border. So in the 0.4 across France, this is about 4.5, 4.6 thousand, so 4,589 road kilometers that seem to be missing to have a perfect network integration. Exactly. So that's what you observed exactly, and it's a bit of an additional evidence the way I see it, because it's in line that you do have less road there. To put this in perspective, this is approximately this 4,000, the size of the regional network of one of the region. There's 100 regions, about 195 departments in France, in metropolitan France, and this is about the size of the network of one of these. Then I assume a road unit construction cost, so 5.4 million per kilometer. I take a 50-year arbitrary 50 years time horizon. You have from the French Road Industry Labor Union annual report, they think that it's about 2 and 5 million euro per kilometer as construction cost, so fixed construction cost. And then you have a renovation cost of 200,000 euros per kilometer every 25 years. So given a 50-year time horizon, you get something like 5.4 million as a clear upper bound, and that's what I'm using. And then floor elasticity to total income. This I also estimate, and I obtain an ETH parameter of 0.81. So you have very good. This is quite large elasticity of as a region becomes more populous and richer, you have quite a good evolution, large evolution in the residential floor space that is available. And the other parameters, these are kind of the standard consumption shares and production shares and things like this that I take from very standard source of the literature. The counterfactual scenario, this is given the function that we had earlier. I simply switch or take off this distance penalty. So I bring this new to 0, and so I'm plotting this when you kind of make the average at the departmental level. So this, of course, I do have the observation. Every unit is at the local level, but I aggregate here just to make it that it just shows well on the map. So this is the log average reduction in the sum over destination of all bilateral travel times, and which I thought was a bit surprising there, is that you do see a bit of you see some regions that have lower reduction, and in here this is where you have the largest reduction. That being said, and this is not surprising because this is fundamentally based on great circle distance, as you can see, reductions are very minimal there. So basically, this is the counterfactual is I integrate completely. I assume that you build these 4,500 kilometers in the right way of a regional road, and you have full integration. The cost benefit of this is so panel A, I'm showing you the total residential income growth, and panel B is the total workplace income growth. As you can see on the horizontal axis, sorry, you see that the magnitude is extremely different. This is not too surprising, given that the framework really targets commuting, and that you have this agglomeration economy. So kind of the anchor point is going to be the kind of the firm side works a bit more as a kind of the anchor point, and then it's the residential density of the people that are going to move, and then suddenly there's no border, so they can move a bit further away, and then you have for each location for every firm kind of a labor pool that is a bit larger. And so the gains the gains are positive in both cases. You have a median growth on residential income of 9.5%. So this is quite sizable. The average is quite larger because you have a few that gain a lot, and I will show you a map in a second. These are the guys kind of in the second row from Paris that until now were badly connected, and as you integrate them, it becomes possible to go work in Paris. And from a workplace income, you see the growth. You also see a growth, an average of 0.2 and a median of 0.52%. So relatively small effect on the workplace side. So it's really residential kind of effect. So how are the gains and losses distributed? So panel A is the total residential income. What you as I told you, you have a few that gain a lot, so almost double in residential income. So this is this department. So for the French among you, this is the Yvelines, this is Paris here, and this is basically at the moment at the border of the Paris metropolitan area. If you were to kind of get a CC kind of city clustering algorithm around this, you would probably enter a bit of the Yvelines, but not too much. And this is exactly what you so this is the region that gains a lot, and the same thing for those a bit further out, where total residential income is more than doubling. But this is not that this region persists that much richer, that they gain a lot in population. So this is the residential population. And you see that they gain a lot by 125. So it's almost a pure, they don't get richer, they're just more people coming here at the expense of the rest of the country. For workplace income, the effect is magnitude of the effect is smaller. The one thing is that the Paris city per se gains a lot at the expense of the very close periphery. So the Petite Couronne for those that know a bit of Paris geography. So that was the paper. To summarize or to conclude, there are three main things that I've tried to do here. So one is regional borders are not invisible, to answer the question of the paper, to surrounding economic activity, commuting flows, and residential densities seem to vary discontinuously at borders. Then you have an estimated discontinuity in travel distances. That's what we saw, this 12 to 19 kilometers, which actually does quite well at rationalizing the effects on residential and commuting flows. And if you were to integrate this network, you would have a real per capita residential income gain of about 9.5 million growth, which is quite sizable. Yeah, thank you very much. I'm welcoming questions.
Thank you very much, Gabriel, for this nice presentation. Let's open the discussion.
I'm sorry. Is there a question? I can't hear. I'm not sure.
Yes, perhaps I can start.
Yeah.
Okay, so thank you very much for the presentation. It's super interesting. So I had like maybe two main points. So the first one is, so you say you frame it about our borders invisible or not, but it seemed that a lot of what is taking place is actually roads. And so when you say borders, it depends on what it implies in different contexts. So I was wondering whether the paper is not more about how important are road networks, and that we use borders to get at this, because I mean borders can mean very different stuff, and so I'm wondering whether you would not want to frame it as actually using borders as a test for like road discontinuity.
Mm-hmm.
And so relatedly, I was wondering whether you could say a bit more about what those borders also imply, because I get that to make the point you want to make in the paper, you would also need to convince that other stuff that vary at the borders are not explaining this. I mean, department are also in charge of like high schools, of some like social assistance and stuff that might like, I don't know, put some constraints on people location and work location. And finally, I was wondering what do you have in mind when you think about the decisions of people of where to locate? So then it's difficult to understand why you would have anyone locating at the border of like a department that has a very higher economic activity. Like, just how do you think about how people choose to locate, and what would be the impact on housing prices of having more roads between departments as well?
Yeah, thank you very much. How should we proceed, Marie-Lionel? Should I gather questions or answer one by one? What do you?
Or you can answer if you want.
Perfect. Then, so this idea of the road network, I mean, this is I do see your point in the sense that indeed the road network seems to be the main driving factor there. But why it's driving? It's because there is a border. So it's not so much that, so in a sense, the border determines how the road network is going to be, which then determines economic activity. So in a sense, to me, the border seems to be the primal cause, the first cause. And this is why I phrase it a bit like this, but clearly the effect goes through the road network. Then about the question of other things. So this is what I had here. I went maybe a bit quick on this. I was a bit quick. So on the spending, they are in charge of basically four items. So the social programs. So this is really mandated. They are very, I mean, this is a very large set, so going through all of them, it's probably infeasible. But for the main ones, there doesn't seem to be large differences. Regional roads, so that's the point. Then I've tested for secondary schools, and there is no difference typically in density or pupil around the border, so that doesn't seem to be much the effect. Same thing for fire departments. That being said, and this is why, because I can't test for all social programs, and it's hard to kind of to exclude, to prove exclusion in a sense. So what I'm trying to do here is this is why I'm using the kind of the structural model to say, okay, there might be other things, that's true, and I can never rule it out, but I have a very compelling good that does quite well at explaining the effect, looking solely at regional borders. So that's kind of the argument here. And the way I think about residential location, I mean, fundamentally, what I'm thinking is people that locate just at the border, these are people that might want to go further away, to maybe get lower housing prices and things like this, but just at the border, suddenly, to go 1 more kilometer away from a great circle distance perspective, it actually implies quite some distance in commuting. So this is why you kind of get a huge jump, and you get this kind of excess mass on that side. And this is how I rationalize. It's not that people care per se about the border. What they care about is commuting time, or commuting distance. And this is why, just that there's kind of a discontinuity there, and they're not willing to get a bit lower housing prices. They're not willing to go to go 12, 19 kilometers more away from their workplace. This is why they just kind of excess mass at the border. But thank you very much.
Albert Soleolé,
Yes, hi.
Hi.
Hi, Gabriel. Nice research. So it gave me, a lot to think about. So one thing that I don't know, but maybe I'm missing, a bit is that you talk, about departments, but what about the cities? Because maybe I'm wrong, but to me, the department at the end is, let's say, a large city, a capital city, surrounded by some suburban or smaller cities and by a lot of rural land. So the problem for the policymaker when designing the borders, is to define some efficient administrative unit that you already know that in some cases is going to be too large, and in some cases is going to be too small.
Just too small, yeah.
So in places where it's large enough, because let's say the city, which is in the middle, is not that large, obviously there's going to be a border effect related maybe to this road infrastructure, maybe to other things, but the cost is going to be small and bearable because you want to have this efficient administrative unit. So the problem gets when the city grows and grows, and it's the economic activity and population is approaching the border. Then you think, oh, maybe it would be a little bit more efficient to have a road to cross the border, because obviously we know that all these capital cities of each department are connected by the main national road network. So this is not the problem. But at the beginning, the most efficient thing is, guy, if you want to work, you take the local road and you go to the city and work there. If you are a firm and you want to trade, you take the national road and go to the other city in the other department. So the thing is that when you introduce the cities, then you see that the whole thing, it actually depends not really on whether this road network is well designed or not, because you already have local roads and national roads. It depends a little bit on whether the size of the department at some point becomes too small given the size of the city.
Mm-hmm.
And this is what you find near Paris. And what this is saying is that the size of the departments around Paris are too small, because the real Paris is much large, than what the departments mean. So look, at the end, it seems that what you are doing, it's true, it's about roads, but it's about, again, whether you should change the borders of departments and amalgamate departments. Is that right?
I would I would take it a bit. So I see your point. In a sense, it's also linked to this kind of urban part on between the metropolitan and the administrative borders. So I think there are two things that I want to answer there. So first, all the natural experiment results hold when you exclude Paris. So these patterns exist without Paris. Just to say that this is in the end the effects, because when you have a GE,
of course, but I said that these effects are going to be there always, because there is this
exactly
trade-off between having an efficient administrative unit and accepting some costs, accepting that this is going to force people to go to the capital instead of going to the other
somewhere
side.
else. But there, in a sense, we are already now at a situation where you have millions. I don't remember the figure exactly for France. I should have it here, but I think it's about 4 million people that every day cross a departmental border. Mm-hmm. So we're already at a moment when many people do cross. So this idea that you have kind of a department and one city in the middle, and basically no one comes from work that city from on the another one. This is not what is happening there. And then to add to this, my point is I fully admit and agree with you that there is some type of inefficiency that is inherent in getting in drawing these borders, and actually the way they are drawn might, except for Paris, which really goes overboard, might actually be quite good way, in the sense that it may potentially minimizes this inefficiency. That being said, we don't have to stop there. So probably if I go one step further in the policy recommendation, And in line with the model, what I'm saying is that it probably would be nice to have one national institution that is in charge really of looking at roads at the border and connects this at the border. So basically, even with the most optimal regional border design, let's assume we are there, it would probably still nice, and there are benefits and positive cost benefits, or even after cost, of bridging this gap. That would be my answer.
Good.
But thank you very much.
There is still time for 1 or 2 questions.
Perhaps if I can add something, but I want to let, yeah, I do not see hands. So I just wanted a little thing. So when you look, at which one is the like richest or had the most employment, when you look at 2 different regions, I was wondering whether you can get also into the intensity of the treatment. So, how when the gap is even like larger, you have like a higher mass of people right at the border. Not only a 1-0 who is the like richest, but whether the gap is large or not. It would be interesting to show how it evolves with the gap. Is it monotic, like completely increasing linearly with how much like different there is between the two or not? That's interesting.
So you mean on the counterfactual predicted population? So kind of the data that is behind this?
No,
the
it
analysis?
was just the like the empirical evidence without the model, where you just show that there is an excess mass of people located on the side where you have more employment.
But using kind of the subsample from those that gain a lot or those that lose a lot? Or did I misunderstood?
My point was just, it seems to me that you were coding one for the one that is richer than the other.
From the larger labor market. Yes, no,
yes.
Sorry, yes, exactly. And I could have actually a continuous, how much larger.
Yes, exactly.
Absolutely.
So you have a continuous gap, and it would be interesting to, just document how it evolves with the gap, because we would expect it to be even higher when the gap is higher.
Absolutely. In a sense, kind of a treatment intensity, as you said, exactly. Yeah. And that's a good idea. Thank you very much. Yeah.